These are notes for section 1.4, solving absolute value equations, day 1. An absolute value equation is an equation that contains an absolute value sign. So if we have an equation, on one side of the equation, or possibly both, you must have an absolute value sign. And inside we can just put x plus 4, for example, equals 10. We are going to go over the properties of absolute value expression or equations. This number on the right side, because we're taking the absolute value of this expression, that number on the right side must be positive. So that's actually your first property. If we let a and b be real numbers, the first property states that the absolute value of a must be greater than or equal to 0, which means whatever's in that absolute value sign comes up as positive. The next property states that the absolute value of negative a would be equal to the absolute value of positive a. For instance, if we take the absolute value of negative 6, that would equal the absolute value of 6. The absolute value is, all it's asking is how many units away from 0 is it? So negative 6 is 6 units away from 0, and positive 6 is also 6 units away from 0. So the absolute value of negative 6 would equal the absolute value of positive 6. The next property states that the absolute value of a times b is equal to the absolute value of a by itself times the absolute value of b by itself. Okay, for instance, let's say absolute value of negative 2 times 4. That's going to equal the absolute value of negative 2 by itself times the absolute value of 4 by itself. So the absolute value of negative 2 times 4, well, negative 2 times 4 would equal negative 8. Take that absolute value, you're 8 units from 0. On the right side of this equal sign, we have the absolute value of negative 2, which is 2, the absolute value of 4, which is 4. 2 times 4 is 8. So they are equal. The last property, very similar to the number 3, only we deal with division. The absolute value of a divided by b is equal to the absolute value of a by itself divided by the absolute value of b by itself. Now, on this property, we have to be careful because we're dealing with a fraction. So b, because it's in the denominator, cannot equal 0. And those are your 4 properties for absolute value. Now, let's get into an example for this unit. If we have a times x plus b in the absolute value sign and it's equal to c, c must be greater than or equal to 0 as we've stated already. And that's a greater than sign. But what you have to realize is inside this absolute value sign, this expression can equal c or it could equal negative c, because once you take the absolute value of negative c, you'll get c. So in order to solve this, we would set ax plus b equal to c and solve for x, or we would set ax plus b equal to negative c and solve for x, and that would actually give you 2 answers to these types of problems. So example 1, let's dive into it. We have x minus 4 in the absolute value sign equals 6. So we're going to make x minus 4 equal to 6, and we're going to take the expression inside the absolute value sign, x minus 4, and we're going to make it equal to negative 6. Now watch what happens when we solve. When we add 4 to both sides, we end up getting x equals 10, and if we add 4 over here, we end up getting x is equal to negative 2. So the first answer may be pretty obvious to you. You're like, yeah, if I plug 10 back in there, we have 10 minus 4, the absolute value, is equal to 6. Well, of course, because 10 minus 4 is 6, the absolute value of that equals 6. But over here, this might not have been so obvious. This answer is negative 2. If we plug negative 2 back in, you have the absolute value of negative 2 minus 4. Is that equal to 6? Well, negative 2 minus 4, some of you might like to think of negative 2 plus negative 4. That would be -6. And when you take that absolute value sign, or absolute value of -6, you get 6 as your value. So that's why it works to set it up to the positive number as well as the negative value.
1b, we have 3x plus 1 in the absolute value sign. So we're going to take that and make that equal to -5. We're also going to take 3x plus 1 and make it equal to the opposite sign, +5. So now it's just a multi-step equation. Let's solve. We're going to subtract 1 from both sides. We get 3x is equal to -6. Divide by the 3. And you have an answer of x is equal to -2. And if you check that pretty quickly, -2 substitute in for x times 3 is -6. -6 plus 1 is -5. The absolute value of -5 is +5. Uh-oh. So when we check it, there's no way that this could equal -5. Nothing that we put in here is going to equal -5 because when you take the absolute value, you should get a positive number. This does not follow this property up here. So you do not need to solve and check. If you ever see a problem where everything on one side is inside the absolute value sign and this is negative on the other side, then you can answer no solution. All right, let's move on. So for this one, we have the absolute value of 3x plus 9 minus 10 is equal to -4. And right away you might say, hey, Ms. Brand, this is negative. We can't solve it. There's no solution. But let's bring down the other example. The difference between this example versus this example is that everything on the left side is inside the absolute value sign, whereas over here, that's not the case. We have this -10 that we first need to move before we can say, is it possible? So let's add 10 to both sides. Because the absolute value, you also want to think it's like parentheses. So we're going to keep this together, get rid of everything else first. So once we do that, look what happens. We have the absolute value of 3x plus 9. This is gone, is equal to +6. So there are some solutions that are going to work because this is now positive. Now we have two setups. We have 3x plus 9 is going to equal +6. And 3x plus 9 is going to equal -6. When we solve, we're going to subtract 9. And we end up with 3x is equal to -3. Divide by 3. And your first solution is x is equal to -1. The next solution, we get there by subtracting 9 again from both sides. And then you get 3x is equal to -15. And then when we divide by 3x, we end up getting x is equal to -5. So here are your two solutions. The next two problems are on your own. I would like you to pause the video, solve for D and E, and once you're done, unpause the video and check your work. Here are the answers for example D and E. On this page, I would like you to complete F on your own, pause the video, and complete only F. We will do G together. Hopefully for letter F, you have x is equal to 6 and -2. For letter G, there's a couple extra steps that we're going to do. So the first thing is we have -2 times the absolute value of 5x minus 1 minus 3 is equal to -11. Remember, when we're solving for a variable, we're going to use the order of operations backwards. So the first thing is anything on the left side being added or subtracted to the variable that's not in parentheses. And I realize there are no parentheses here, but your absolute value has the same qualities or the rules as a parentheses. So everything inside the absolute value is going to stay together until the end. So we have a negative 2 that's being multiplied to everything inside the parentheses, and we have a negative 3, or we're subtracting 3, which is one of the first things we're going to get rid of. So we're going to add 3 to both sides to get rid of that. And now we have the negative 2 times the absolute value of 5x minus 1 is equal to negative 8. Remember, the absolute value, whatever's in it, is going to stay inside together until that's all that's left. So we have to get rid of this negative 2 that's being multiplied. So the inverse of multiplication is division. We'll divide both sides by negative 2. So now we have the absolute value of 5x minus 1 is equal to positive 4. I just try to stress that these are the absolute value signs. Make sure they don't look like ones, and then you just get confused. Now, the only thing that's left on the left side of the equation is inside an absolute value. So at this point, we're going to write our two equations. 5x minus 1 is equal to 4, and 5x minus 1 is equal to negative 4. So when we solve, we're going to add 1 to both sides. Then we have 5x is equal to 5. We'll divide by 5, and our first answer is that x is equal to 1. On this side, we'll do the same steps. We have add 1 to both sides, and we get 5x is equal to negative 3. And when you divide by 5, your answer is x is equal to negative 3/5. So those are your two answers for those problems. All right, these word problems are a little bit different. I'm going to teach you how to do example 3, and then the on your own is very similar. So it says, in a cheerleading competition, the minimum length of a routine is 4 minutes. The maximum length of a routine is 5 minutes. Write an absolute value equation that represents the minimum and maximum lengths. So the way that you do this type of problem is, let's first say, okay, we have a routine that's 4 minutes at least, 5 minutes at most. So what you have to do is you have to find the midpoint between your smallest value and your largest value. And for us, that would be right here at 4.5. So there's two things that you need. You need the midpoint, which is 4.5, that value. Then the second thing you need is, I need the distance between my minimum point and the midpoint. The maximum point and the midpoint, that distance, these two will be the same. So between 4 and 4.5, the distance is half. Same thing on this side. The distance is half. Okay, so we're going to use these two numbers, the 4.5 and the half. And the way that you write an equation is you would take the absolute value of x minus the midpoint, which is 4.5, close the absolute value sign, it's equal to 0.5, which comes from the distance of the midpoint in either your maximum or your minimum value. So now if I solve this, if we had x minus 4.5 equals 0.5, or a half, and we have x minus 4.5 is equal to negative half. When we solve for x, we're going to add 4.5 to both sides. And our first answer is that x is equal to 5. Well, that's the longest that our routine can be. And over here, when we add 4.5, we get x is equal to negative a half plus 4.5 is equal to 4. And that's the minimum amount that our routine can be. So this is the equation that you need to write. Pause the video, do the on your own word problem, unpause it, and check your answer. I have not finished the on your own, but I wanted to show you if you have numbers such as 16 and 32, it may be a little bit more difficult to figure out your midpoint. So what you can do is you can take the difference between 32 and 16, which is 16, and then you can divide 16 by 2 to get 8. So from here to the midpoint, it would be 8 units away. And from here to the midpoint, it would also be 8 units away. So 16 plus 8 is 24, 32 minus 8 is 24, so that's your midpoint. At this point, to write the equation, you would say x minus your midpoint of 24, absolute value, is equal to the number of units to the midpoint, which is 8, and that would be your equation. This concludes your notes for section 1-4, day 1.